This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Algebra 1B, Learning Target number 5. I can identify the domain and range of an absolute value function. So hopefully you've already snuck a peek at the video for learning target number 2, in which case you probably don't even need to watch this video because you'll know what to do. If not, I can help you out right now. So domain and range are asking you for what are all the values that x can take on in this relation or function, and range is asking for what's all the values of y, that up and down, that the function can take on. So let's talk about domain, or your x, first. So here is your x-axis. And for absolute value functions, they are meant to, although this graph doesn't show it, extend into infinity in both directions. So in this case, we've got this continuing right on and on and on and on and on forever, and this one continuing left on and on and on and on and on forever. So really, there is no maximum value where this function's going to stop for x. It'll keep going to positive infinity, and there is no minimum value for x here. That's just going to keep going towards negative infinity. Easiest way to express this is to say that the domain is all real numbers. Now for range, that's your y value, and that's going to be a little bit different because this function does turn around, stop, and start going back in the other direction. So let's see what are all the values that it can take on for y. It looks like since this points up on and on and on and on and on for infinity, then it will keep going all the way up to positive infinity, well past this 7 that you can't see. However, there is a minimum, there is a bottom, and this is at 3. This is as low down as it goes on the y-axis, so we say that is a minimum. Now there's a couple ways that you can express the range here where there is a value that is a minimum. There is a stopping point. So one way is in interval notation. That's the less than, greater than kind of symbols. And in this case, you would say y has to be, notice that y is going to be all the numbers that are bigger than 3, not less than 3, greater than 3. Y is going to be greater than or equal to, because it does barely touch that 3, 3. Or if you like, you can use interval notation, which is my favorite. And it's kind of like a coordinate point where you just write what the minimum and the maximum is. So in this case, our minimum is here at 3, and it's exactly at 3. So we're going to draw this kind of like a coordinate point. The minimum comes first, and then the maximum comes second, separated by a comma. In this case, our maximum is unbounded. It keeps going up to positive infinity forever. And now normally we close these off with rounded brackets like we would a coordinate point. However, in this case, we're going to use a rounded one for the infinity, because infinity is not an actual set exact number. It's a concept. So we're saying it ends somewhere around infinity. However, there is a hard stop minimum at 3, so we're going to put square brackets at 3. The minimum is exactly at 3, so we're putting exact brackets like this. Let's try it for this function right over here. Let's start with our x values for domain. And again, don't forget that although it doesn't really show it, for absolute value functions, they do extend forever way off the small snippet that this graph shows. So let's consider now what all the values of x could be. It looks like it goes, oh, that's going to keep going left forever, isn't it? Yep, negative infinity. And then, yep, it keeps going, it keeps going, it keeps going, keeps going, keeps going, all the way off the page to the right forever up to positive infinity. So it's all real numbers for the domain. Big hint, that's what it's going to be for all of these questions. Don't even think about it. And for range, this one also has a bottom. It has a minimum. But notice that these arrows go up forever. So for the y value, that's all the way up to positive infinity up here. But then there is a stopping point. Where is it? There's the bottom. Where does that hit the y-axis? That's right here at 1. The least value that y can be is 1. It's never going to be any lower than that. So our range is going to be y has to be greater than or equal to 1. Our minimum is 1. Our maximum is positive infinity, somewhere around positive infinity, but exactly starting at 1. Now, if your absolute value function is pointing downwards instead, in that case, you would have a maximum, and your top value would be on this one instead, and it would keep going down to negative infinity for your first number here. But I think these ones are all going to be positive. Thank you.